Good morning, everyone. I welcome you all for this session of projection of solids. Let us begin with the problem. A hexagonal pyramid, 25 sides of base and 50 axis length, rests on HP on one of its edges of the base. Draw the projections of the pyramid when the axis of is inclined to HP at 45 degree and VP at 30 degree. I have a hexagonal pyramid of 25 sides and 50 axis length. It is resting on HP and on one of its edges of the base. So I can understand two questions I can solve. That is where it is resting and how it is resting. It is resting on HP and on one of its base. So today's problem, let us begin with the software. The first thing as soon as I open a window is my sheet setup. So I'm going with my sheet setup with the A4 sheet, then feed it with my window. As soon as I get a problem, I'm going to draw my XY line. So this is my XY line of thickness 0.13. I'm going to name this XY line with capital X, capital Y. This part is VP above my XY line, and below my XY line it is HP. Once I'm done with, I need to draw a hexagon. In a software, to draw a hexagon, I'm drawing it with only one at a one stretch. The base hexagonal base is of 25 So let's begin with the 25. The length is 25. The angle at the beginning it is 0. Then 25, the angle of the hexagon is 60. Then it is 25, it is 2 into 60. 25, angle is 3 into 60. Length is 25, angle is 4 into 60. Length is 25 and 5 into 60. This is my hexagon. But I have drawn a hexagon in such a way that I have a corner on my right hand side, but when I read a question, I have a edge resting on HP. So I should have a edge of this hexagon to my right hand side. So for which the first thing is I'll just rotate this hexagon. I'll select the whole thing. I need to rotate it without copy, so I deselect this rotate copy. Then I select the first point of center of rotation, and the next is the point from where I need to rotate from. So I rotate this to 90 degrees such a way that I get my edge on my right hand side. So once I rotate, I need to move it to its position. So I select this whole hexagon. Let's do it once again. From the center of rotation to from where I need to rotate. So I just go the other way around. Once I do this, I need to move it to certain position. I can move it. And also the thickness of this hexagon, I have to select it at the beginning, or you can change it now by selecting the whole hexagon. The thickness of this should be 0.5. Once I'm done with, I need to know the center line of this, and the thickness of this should be 0.5. I'm going to join two opposite corners. These meet at a point, and that is for me nothing but, this is for me, it is nothing but my center point. Then I project this hexagon on top. Once I am projecting it, now I need to know the axis line. I'll just draw the axis line first by selecting the chain line here, that is the third line. The length of this axis, they have given it as 50 mm. So I enter 50 in the length, and angle is 90 degrees. Once I do it, I need to complete this with the pyramid. I join all the lines with the thickness of 0.5. So from the apex to my this point, I'm sorry, the lines, I need to go with the straight line. That is continuous line. So I select this from here to this point. Then also I have from here, when I can see a corner where I have to draw a line from this point to this point. So again I'm drawing a line from here to here, where my axis line, if I don't draw, that is fine, because it is going to be merged with the line which I'm seeing from this end to this end here. That is, at this corner I have a corner, so I have a line coming from this center, that is apex of the uh, pyramid, to the base corner. So because of this, I have a line coming from O1 to O2. So I just name these hexagon, the base corners. This is A, this is B, this corner is C, this corner is D, then E and F. Also I have at the inner end, I have O1 outside the bracket, I have O1 outside the bracket, as well as within the bracket I have O2. The same things when I see from here, from this end, if I see from this end, I can see three corners, that is B, C and D. When I can see three corners are visible from this end. That means whatever I get here, it is nothing but I get B dash outside the bracket, and A is merging with B. So I cannot see A when I'm seeing from this end here. That means A dash will be within the bracket. So I get A dash inside the bracket. Similarly, I can see C here, but I cannot see F, nor can I see O2. So I cannot see F and O2 because it is getting merged with C. So C is outside the bracket. So I write this as C dash, and within the bracket I have f dash and O2. And at this end again I have D is visible, E is not visible. So I have D dash outside the bracket, and within the bracket I have E dash. I have not completed this pyramid. I need to draw these baselines, and I'm going to split these baselines to each corner. So from here to here one corner, and from here to here the other one. Okay. Now in the third one, I'm just going to copy the whole thing, and I'm going to rotate in the third diagram of this figure. So for which I have to complete, this is my O1 dash. Now what I do is I select this whole top front view. I select this whole front view, and I'm going to move this with copy. So I'm going to move it with copy. I select this part, and I'm going to select from the point to move from. So this is my point I need to move from. So I'm going to move it to this end. Once I do it, I need to rotate this whole thing. So the first is I need to click for the center of rotation. So this point is my center of rotation. Then I'm going to click on the point to rotate from. So this is my point to rotate from, and I need to rotate to certain angle. And I know the axis is inclined to HP at 45 degree. To HP at 45 degree. And I'm interested in, I'm going to convert this axis inclination to base inclination. In that case, it is nothing but 90 minus 45. So the angle of this base inclination is also 45, but in our software, it takes from, this is my 0 to this angle. So it is nothing but 90 plus 45. How much it is? 90 plus 45. The angle will be 135 degrees. So I'm going to rotate to 145 degree angle of rotation. So once I do this, I'm going to project all these downwards directly. Next is I'm going to project the lines sideways with the thickness of 0.13. I have A from this end, then I have A from this end. Then I have B from here, B from here. Then I have E from this end, F. This is my C from this end. Then I have D from here, as well as I have E from this end. So now I just join the lines. I know all the corners starting from A, B, C, D. So I just named them. This point is A, It is A from here and A dash from here. It meets at a point, and that point is for me, it is A. And this is B. Then I have C. This corner is D. This corner is E. And this corner is F. Once this is done, I need to project the apex. I'm going to project the apex with the thickness of 0.13 to this end. Now what I do is, the first thing what I'm going to do is, I'm going to complete the outside points, draw the lines for the outside line, so that I complete first is the outside things. So starting from A, it is A to B, B to C, then it is C to O1 dash, C to O1 dash, then O1 dash to F, then F to back to A. I'm going to project this sideways. The thickness of this line should be 0.13. Then I'm projecting this sideways. Then this to the bottom. Then this to O2. Okay. Now I have got my points, that is corners. This is A from this end, A from this end. Then this is B from this end, B from this end. Then I have C from this end and this end. Then I have D, then E, and this is F. This corner is O1, and this corner from here I get as O2. Now what I do is, I'm going to join first the outside lines with the thickness of 0.5, that is starting from A to B, B to C, C to O1, O1 to F, and F2 back to A. First, always what I'm going to do is draw the outside part of this pyramid. So I'm starting from A to B, B to C, C to O1, O1 to F, F to A. Now I'm going to check for my dotted lines, and the line going out from this point will be dotted line. So I have 5 lines going out from this end. It is D to E, E to F, and D to C, as well as D to O1 and E to O1. I repeat, from this end I have D to E is one line, E to F is another, then I have D to C, then D to O1 and E to O1. So these are my dotted lines where in which I need to draw those. So I select the line option here, then D to E, from D to E, then E to F, then I have D to C, also I have from D to O1 and E to O1. So that is all for this fourth diagram. Then I need to draw a line here. I can draw a line axis inclination anyways I can draw. So it's not necessary it should be only like this or it should be only like this. So whichever is convenient for us, we can draw on that way. So I'm going to draw a line here on in this manner. So the axis inclination in the third position we have the axis is inclined to VP at 30 degrees. I have an axis inclined to VP at 30 degrees. So again when I read and I check my axis, in this position it is 50 mm and in this position it is less than 50 mm. So when the axis in a length is changing from the first position to the fourth position, that means it is a locus problem. Whether I have to draw a locus or not, it depends on the question, for which again I need to go back and read the question, for which I should not have appears to be words in the question. If I have the axis appears to be at to VP at 30 degrees, I'm not going to use locus method. Here, when I go back, read the question, I don't have any appears to be word or it is only VP at 30 degree. That means it is a locus problem. So for which what I do is I draw a line of 30 degrees. Let it be of any length. So let me take it of any length and it will be again of 30 degrees. So how do I draw 30 degrees? Yes, my angle it starts from here, it is 0, then here it will be 90, then it goes on to 180. So 180, this angle for me it is 30 degrees. So 180 minus 30, 180 minus 30 degrees, it will be nothing but minus 150 degrees. So I have to enter minus 150 degrees if I'm drawing the line like this, in this manner. If I don't want the line in this manner, like as we did in the earlier problems, if I used to draw a line in this way, it is something minus 30 degrees directly. Okay. So again, not a confusion. Whatever I have, I'm just going to place it in this other way around. Here in this way, I'm going to place the other way around. It is one and the same. I'm drawing a line of 145 length. It is just and angle is minus 150. Then I'm going to place this original line, for which I'm going to move it the true length. This is my true length here. So I'm going to move this true length, for which I need to click on a point to move from. So I select this is the point to move from. I place it somewhere on my 30-degree line. Then I'm going to rotate this. I'm going to select the line which I need to rotate, and I'm going to click on the center of rotation. Next is I'm going to click to the point to rotate from, and I'm placing it on this 30-degree line. Next is I'm going to draw a line which is parallel, to the XY line from this end. Then I'm just going to modify this whole thing. I don't have O1 to O2 here. So for which I'm going to draw O1 to O2 in this case. Okay. Then I'm going to select this whole fourth figure. And I'm going to move this whole thing. And this I'm going to move it from this. I'm going to select the first one, that is point to move from. So this is my point to move from, and I'm going to place it on O1. Then I'm going to rotate this. I need to select the center of rotation. Then I'm going to click the point to rotate from. I'm going to rotate from this point, and I'm placing this point in such a way that it touches my new locus. So that point touches my locus. So I just repeat once again. I'm going to select a rotate command, select this whole cone, then select the center of rotation and select the point to rotate from. So this is my point to rotate from, and I'm placing this point in such a way that it touches my new locus. Okay. So with this, I'm done with my fifth figure. Next is my sixth figure, where I'm just going to project from A from this end and A from this end. Sorry, these are continuous lines, and the thickness of this is 0.13. So like that, I'm going to just take it from here. This is A, then I have B, Then I have C, then the point D, and close this whole figure and join the lines coming out from this meeting points.